Troubleshooting guide. Battery issues. The EV's battery pack is usually the most expensive and critical component. Properly diagnosing battery issues can save time, money, and prevent safety incidents. In this section, we'll cover troubleshooting for rapid discharge or range loss. The battery seems to drain too fast. Thermal runaway or overheating concerns. Battery getting dangerously hot. Cell imbalance problems. Uneven cell voltages causing performance issues. Each problem has distinct symptoms and a systematic approach to diagnosis. Let's break them down one by one, with practical steps and examples. Battery rapid discharge, range dropped. Symptoms. The vehicle's state of charge plummets quickly under use, or the range is significantly lower than it used to be. The driver might report something like, "I charged overnight," but after driving just 20 kilometers the charge is nearly gone, or the EV might suddenly go from 50% to 20% in a short span. In some cases, the car may even enter a low power mode, turtle mode, unexpectedly due to the battery depleting faster than expected. Possible causes. Rapid battery discharge can result from battery aging, cell faults, or calibration issues. A degraded battery with reduced capacity will of course empty out sooner, normal wear and tear, but if the drop is sudden or abnormal, suspect an issue such as a weak cell group pulling down the pack, or a battery management system (BMS) error. Environmental factors can also play a role. Very cold weather can temporarily reduce available battery capacity. Drivers see range anxiety spike in winters, whereas extremely hot weather can increase self-discharge and load from cooling systems. In Indian cities, using the AC heavily in summer or getting stuck in traffic can stress the battery and give the impression of rapid drain, due to accessory loads. Troubleshooting steps. Check battery health and error codes. Start with the vehicle's diagnostics. Modern EVs often log battery-related trouble codes in the BMS. Use a scan tool to read codes, for example, a code indicating cell under voltage or battery module fault points you right to a weak cell or module. Also, check if the car reports a state of health (SOH) percentage for the battery. If SOH is very low, indicating a worn-out battery, rapid discharge could simply be due to normal degradation. But if SOH is okay, look for imbalances. Inspect for cell imbalance. Connect to the BMS via diagnostic software to view individual cell voltages. An imbalanced pack will show one or a few cells with significantly lower voltage than the others when the pack is under load or near empty. If, say, one cell group hits the low voltage cutoff earlier than the rest, the BMS will cut off discharge to protect the pack, making it seem like the battery dies at 20%. In one service case, an electric scooter in Hyderabad was found to have one bad cell group that would trigger low voltage cutoff while the others were still at 3.7 versus. The BMS had been shutting the vehicle down early, a classic imbalance issue. What to do if imbalance is found? Many BMS have passive balancing that works when charging to 100%. You could fully charge the pack, if safe to do so, and see if the cells balance out. If one cell is far gone, voltage significantly lagging others, it may need replacement or the pack requires rebalancing with specialized equipment. Note: an imbalanced pack effectively reduces usable capacity, so fixing it can restore lost range. Check for parasitic drain or faulty components. Ensure that nothing is drawing power when it shouldn't. A malfunctioning component, e.g., a cooling pump stuck on, or a shorted contactor, could drain the battery rapidly. With the vehicle off, measure if there's significant current draw from the HV battery. Some diagnostic tools or techniques can measure this. Also, verify the 12-volt system isn't discharging the main battery unexpectedly, since DC-DC converters connect them. In one scenario, a telematics unit in a fleet EV was improperly wired and never went to sleep, continuously drawing power and causing the high-voltage battery to drain faster overnight. Firmware, software glitches. Sometimes the issue is not the battery's health, but the reporting. A BMS software glitch might miscalculate state of charge. Check if there are known software updates for the model addressing range or BMS accuracy. If the EV suddenly shows odd battery behavior after a software update, consider that the update itself might be faulty. Manufacturers occasionally release patches to improve BMS algorithms for estimating charge. If an update is available, apply it. If the issue started after an update, consult technical service bulletins. The fix might be to roll back or repatch the software. Environmental and usage factors. Interview the user about their usage. Rapid discharge might simply be due to heavy acceleration, hilly terrain, or towing, if applicable. For example, an EV driven on steep climbs or at highway speeds will drain faster. Ensure the user's expectations align with reality. Extreme climates affect range. Cold weather can seriously cut range, battery efficiency drops, and heating systems consume energy. If an owner in Shimla complains of range loss in winter, it might be a normal effect of temperature, not a battery fault. Advise them on mitigation, like preheating the battery, vehicle while plugged in, etc. Case example, a Nissan Leaf owner once noted limited motor power, warnings and rapid charge drops in cold weather. The cause was the battery's internal resistance spiking in low temperatures, causing voltage sag under load. The fix was simply understanding the limitation and avoiding heavy acceleration when the battery is very cold. No hardware fix needed, just education. Always differentiate between true faults and environmental effects. Resolution. If a defective cell or module is identified, e.g., one with consistently lower voltage and capacity, the long-term fix is to replace that module, if the manufacturer allows module-level repair, or the entire pack if not. Ensure after any repair or rebalancing that you test drive the vehicle and monitor the discharge curve to verify the problem is resolved. Battery overheating and thermal runaway risk symptoms. The vehicle's systems may display a battery temperature warning on the dashboard or limit the discharging rate. In severe cases, the battery may go into a thermal runaway, an uncontrolled temperature rise, which is a very dangerous condition. Early signs of impending thermal runaway can include a strong chemical smell, electrolyte vapor, hissing sounds from the battery venting gas, or smoke. However, long before those extreme signs, you might simply have evidence of overheating, e.g., the cabin begins to smell sweet or odd during charging, possible electrolyte leakage, or the battery cooling fans run at full blast constantly. Another symptom is the vehicle reducing power or stopping charging abruptly with overtemp errors. Possible causes: thermal issues can arise from external heat, overstressing the battery, cooling system failure, or internal faults. In India's hot climate, battery packs without proper cooling can run hot, especially if a vehicle is fast charged frequently or driven hard in peak summer. If the thermal management system fails, say the coolant level is low or the chiller is not working, the battery can heat beyond safe limits under normal use. Internal defects, like a shorted cell, can also generate intense heat inside a module. Thermal runaway specifically refers to a chain reaction where a failing cell releases heat, causing adjacent cells to overheat and fail, and so on, potentially leading to fire. It's often caused by manufacturing defects or physical damage to cells. For instance, an initial investigation into a string of electric scooter fires in India, summer 2022, found faulty battery cells and modules as the root cause, which likely led to internal short circuits and thermal runaways. Troubleshooting steps: verify temperature readings, check the battery pack's temperature sensors via diagnostics. Compare readings across the pack. If one module is significantly hotter than others under the same conditions, that's a red flag. It could indicate a bad cell or a cooling channel issue for that module. Also, consider the environment. Is the sensor reading high because the ambient is high, e.g., car sitting in 40 degrees Celsius sun after a drive? Or is it high beyond what ambient would cause? Use an IR thermometer or thermal camera on the battery enclosure if possible to spot hotspots externally. Inspect cooling system. If the EV has liquid cooling for the battery, check coolant levels and the operation of pumps and valves. A kinked coolant line or airlock could be preventing flow. In air-cooled designs, ensure fans are working and vents are not clogged. Dust and debris can block cooling vents, not uncommon in dusty workshop areas or after driving on dirt roads. A simple cause could be a blown fuse for a coolant pump or fan. Also inspect the cabin AC if it doubles as battery cooling. Some EVs route chilled refrigerant to the pack. Is the AC functional? If not, the battery might be overheating due to lack of cooling. Solve any cooling system issues, refill coolant, replace bad pumps, clean filters, and then see if battery temps normalize. Charging station and pattern. If the overheating occurs during charging, examine the charging setup. Is the user fast charging, DCFC, back-to-back frequently? Rapid charging heats the battery more than slow AC charging. Perhaps recommend allowing cool-down periods between DC fast charges. Check the charging current. A malfunctioning charger could be overcharging or not following the proper curve, though BMS should prevent that. Make sure the battery cooling system is activating during charging. You should hear fans or pumps when a fast charge is in progress. If not, that's a clue. Early signs of thermal runaway. If you suspect a cell is in bad shape, for example, a module that consistently reads much hotter or is triggering over temp errors even under moderate usage, be very cautious. Thermal runaway often gives little warning. In workshops, some advanced battery diagnostic tools sniff for vented gases. Off-gassing from a cell, sweet or solvent-like smell, can indicate a cell has ruptured. If you have any indication of this, prioritize safety, detailed in the safety section. Technicians should not attempt to charge or continue using a battery that might be headed toward a runaway. Instead, isolate it and follow manufacturers' protocols for handling potentially unstable batteries, which may include placing the vehicle outside in a safe area, etc. Use BMS data and logs. The BMS typically logs events like over-temperature occurrences. Check how often and when the battery hit high temperatures. If logs show repeated spikes during certain driving conditions or charging sessions, that context can help. For instance, if every time the vehicle fast charges in the afternoon it overheats, the pattern suggests it's an operational stress issue rather than a random fault. You might then check if the cooling system is undersized or if maybe a firmware update is needed to ramp cooling sooner. On the other hand, if a particular cell sensor suddenly started reading 20 degrees Celsius higher than others one day, it might indicate that cell went bad around that time. Preventive insights. Modern research is looking at early warning systems for thermal runaway, such as installing gas sensors to detect the first vent of a failing cell. Some EVs and charging stations now incorporate such sensors or algorithms to catch thermal issues early. As a technician, stay updated if the manufacturer has issued any recalls or service campaigns, for example, to add insulation or spaces in the pack to mitigate propagation. There have been cases where EV makers update the BMS to slightly reduce maximum charge levels or change cooling logic to add safety margin if a risk is identified. Example, e-scooter fire recall. A notable real-world example was the recall of 3,215 Okinawa electric scooters in India after a series of fires. The manufacturer found that loose connectors and battery damage were potential causes and issued a recall to check and repair packs. This underlines that something as simple as a loose connection can create high resistance, heat, and eventually fire. Technicians were instructed to inspect battery connectors for any looseness or corrosion and secure them, a straightforward maintenance task that can prevent disasters. Resolution. If an overheating issue is traced to a bad cell module, the fix is to replace that part of the battery pack, or the whole pack. Always follow manufacturer guidance for battery repair versus replacement. After resolving, do a stress test. Charge the vehicle fully and then discharge, drive or on a dyno, under close monitoring to ensure temperatures stay in range. Never return a vehicle to a customer if you have lingering doubts about battery safety. It's better to keep it for observation than risk a thermal event on the road. Battery cell imbalance and BMS calibration symptoms. The vehicle might shut off or refuse to start even when the display shows some charge remaining, or it might not charge to full 100%. There could be a warning like battery imbalance or generic battery fault light. Also, the range might be lower than expected because effectively part of the battery isn't being used. For example, an EV that used to charge to 100% now only goes to 90% and stops. This could mean the BMS detected a cell hitting the max voltage early and cuts off charging for safety. Similarly, during discharge, at say 20% indicated, the car may shut down because one cell group dropped too low. The symptom is a reduced usable capacity despite the battery physically having more energy if balanced. Possible causes. Cell imbalance can happen over time as cells age at different rates. If one cell out of, say, 100 in series loses capacity or state of charge sync, it becomes the weak link, it hits empty or full before the others. The BMS, trying to protect that cell, will then prematurely stop discharge or charge, leaving energy on the table in other cells. Imbalance might also occur due to manufacturing differences or if the pack wasn't balanced to begin with. Frequently fully charging to 100% on some chemistries, or never charging to full on others where balance only occurs at top sock, can exacerbate imbalance. Physical issues like corrosion on a cell connection or a faulty BMS voltage sensor can also create a false sense of imbalance. Troubleshooting steps: read BMS balance data. Using diagnostic software, check parameters related to cell balance. Many BMS will report the voltage of highest and lowest cell, and imbalance in MV. If the difference is above allowable threshold, often anything more than 20-50 mV is notable. Some cases we see 100 plus MV differences, that's confirmation of imbalance. Also, see if the BMS has any logged cell imbalance fault codes. Some systems log code when imbalance greater than X MV for Y charges. Perform a full charge cycle with monitoring. Often, balancing circuits in BMS only activate at the end of charge, when cells are nearly full. Instruct the owner, or do it at the workshop if possible safely, to charge the vehicle to 100% and keep it at full charge for a while. If the BMS does passive balancing, it will bleed down the higher cells to match the lowest cell. Monitor cell voltages during this process. With luck, the cells may balance out. If, after a full charge, one cell is still significantly off, that cell may have lost capacity or have high self-discharge. Manual balancing or repair. In some scenarios, you might carefully do a manual balance. This could mean charging low cells individually, with special equipment, or bleeding high cells manually. However, this is advanced and needs the right tools and safety measures. Many Indian EV service centers may not be equipped for cell-level repairs. Often the pack or module is swapped as a unit. Use this step only if you have the expertise and the manufacturer's guidance. For instance, if a particular BMS allows cell module replacement, you'd replace the bad module, then ensure its charge matches the rest of the pack before reconnecting, to avoid a jump in voltage. BMS reset, calibration. Sometimes the BMS might get out of sync, e.g., after a sudden voltage drop from a glitch. There are cases where performing a BMS reset can clear learned imbalance data. Some EVs have a procedure, like disconnecting the 12 volts and HV for a certain time, to reset the BMS memory. After that, the BMS will relearn the state of charge from scratch. This can help if the issue was a one-time glitch or sensor error. For example, one tip from technicians: if no obvious hardware fault and the car is stuck in a won't charge past X% loop, try a BMS reset and see if it recalibrates properly. Always ensure to follow any specific steps. Some cars have a hidden BMS reboot option via software. Test under load. Once you think the imbalance is resolved or improved, test the vehicle. Charge it full, drive it down to near empty, if safe, while logging cell voltages. Ensure no cell once again drastically diverges. If a particular cell group still consistently behaves poorly, e.g., it charges to a higher voltage quickly then drops faster than others on discharge, that module is likely defective and should be replaced. In fleet scenarios, keep an eye on repeated offenders. If multiple vehicles of the same batch start showing imbalance, it could hint at a design issue or batch problem in cells. Example, a fleet of electric rickshaws in Delhi noticed that after a year of operation, some vehicles would stop with approximately 30% charge still indicated. Technicians found that the cheapest cells used in those packs had high variance. A couple of cells lost capacity faster, so the BMS was cutting off early due to them hitting low voltage. The interim solution was to frequently top balance the packs, charging fully overnight, so that the weaker cells could get dragged up as much as possible. Long term, the fix was installing better quality cells and updating the BMS firmware to balance more aggressively during every charge. Resolution: balanced cells mean the EV can use its full capacity again. So, after service, the owner should notice that the range is back to normal and that the car charges to 100% without early cutoff. Emphasize to the user good practices. For instance, if the manual recommends an occasional full charge to balance, they should do that. Also, extreme use cases, like storing the vehicle at 0% or 100% for long times, can worsen imbalances. Educate them on maintaining mid-level charge during long storage, etc. Ultimately, if a particular cell is bad, replacing it, or the module, is the reliable fix. After replacement, Always update the BMS records if required. Some BMS need to be told a new module is in place, and verify everything again.